Okay, in this topic we will cover the next chapter, which is sequence series. So we have arithmetic sequence and series, okay, which is an arithmetic sequence series is one in which the difference between successive terms is a constant number. For example, you have a constant number of 2, 5, 8, 11, 14. So this is a constant number, have a arithmetic sequence. For example, we have 2, 0, negative 2, negative 4, negative 6, okay, negative 8. So it's going towards the negative value with a sequence of arithmetics. So in general, the sequence has this form of a plus kd, which is k is a constant of starting from 0 and the rest, and also n minus 1 is the sequence of the series, where your a is the first term, d is the common difference, and n is the number of terms in the sequence. Okay, for example, the general arithmetic sequence, we know that Sn is a plus d plus a plus 2d plus a plus 3d dot dot dot, or means in term of mathematical, we can say a plus n minus 1 times d, whereas your k is equal to 0, started from 0, then your n is n minus 1. So this is your mean. Okay, so in order to obtain the expression for sum of n term in the series, so we can write up Sn equal a plus d, a plus 2d, then equal to a plus n minus 1d. Another one, we can say that Sn is a plus n minus d, a plus n minus 2d, a plus n minus 3 times d, then the rest. When we sum these two expression series, we can get 2 Sn equal to 2a plus n minus d and the rest. And when we take Sn is the sum of all the series, so finally we will get the main equation of 1 over dn times 2a plus n minus 1 times d, which is your a is first term and d is last term. Okay, if we go for example of arithmetic series, okay, this is example of arithmetic series. So the question asks us how many terms of the arithmetic series of 11, 15, 19, etc. will give a sum of 3, 4, 1. Okay. So here the solution is so for example, you have your a equal to 11, which is your first term. Then you have your d is, we take t2 minus t1, or means that this is t1, this is t2, and this is t3. So the difference of t1 and t2, so means 15 minus 11, you will get 4. Okay, so we know that Sn is equal to, the summation is equal to 3, 4, 1. So based on the previous equation, we know that the equation of sum is 1 over 2n times 2a plus n minus 1 d. So here we know that the Sm is equal to 341. So here you have 1 over 2n times 2. What is your A? A is 11 plus n minus 1. What is your D is 4. So you get 341. Then you will get n over 2 times 22 plus 4n minus 4 is equal to 341. Then n over 2 is equal to 18 plus 4n is equal to 341. Okay, so here you will get n 9 plus 2n is equal to 341. So you will get 2n square plus 9n minus 341 equal to 0. So here you get 2n plus 331, another one, n minus 11 equal to 0. So finally you will get n is equal to negative 31 over 2, or n equal to 11. So in this case we are taking the positive value. Your n is 11. Okay, so this is how one of the example to calculate arithmetic. The second one, can go for second example of arithmetic equation series. Okay, example we have a contractor agrees to sink a well for 40 meters deep at a cost of 30 ringgit, $30 for the first meter and $35 for the second meter, and increase by 5 for each of the sequence. Okay, so from here we know that our A is 30. Okay, then our D is 5 and our N is 40. Okay, so question 1 is, what is the total cost of sinking the well? So the total cost is Sn is equal to 1 over 2n times 2a plus n minus 1 d. So we know that 1 over 2, what is your n? N is 40. Then we have 2, what is your a? Is 30 plus what is your n? Is 40 minus 1. Then your d is 5. So from here, when you solve this one, you will get is 5,100 euro. So this is the total cost of the well. So this is for A. And for B, what is the cost of drilling for the last meter? So we know that the last meter is Tn is equal to T40. Okay, so T40 is equal to this one is equal to A plus so you get A plus n minus 1 d. So what is your A? Is your T plus n is 40 minus 1. Your D is 5. So total up you get, the final one is 225. Okay, so this is the summation, this is the term. Tn is a term n. Okay, Okay, we go for next example. Determine the number of odd number between 20 to 30. So we can start with 20. What is the first odd number? So you know that first odd number is 21, the second odd number is 23, the third odd number is 25, and the rest it will end at 299, the odd number. So from here we know what is your A. A is 21. What is your D? D is 23 minus 21 is equal to 2, and your T N it will term of 299. So the question is, what is the number of odd number? So the number of a number is, we use the A plus N minus 1 times D is equal to 299. So how many odd number? At the end it will be started from 21 until 299. So what is your A is 21 plus what is your N? This is what we want. What is your D? D is 2 is equal to 29. Okay, so we'll get 21 plus 2n minus 2 is equal to 299. Then we will get about 2n minus 19 equal to 299. So you will get 2n is equal to 280, n is equal to 140. So this is example of, we want to know what is the amount of n. Okay, bilangan n or odd number. Okay, so we go for the next example. This is example of, consider the arithmetic series below. So we have 1000, 988 half and 977. Determine the first negative term. The first negative term. So we have to have the n. Okay, the first negative term. So means your solution should be, as usual, you should have your A. In this case your A is 1000. Start with 1000. What is your D? D is 988 1 over 2 minus 1000. You will get negative 11 1 over 2. Then determine the first negative term. So the term formula is A plus N minus 1 times D. The first negative term, so should be below than 0. So the first one to become is 0. So the value that below from 0. So you have your A is 1000 plus what is your N? N is negative. Sorry, N is what we want to find. N minus 1. And what is your D is negative 23 over 2. It's below than 0. So when you solve this equation, you will get about 2000 minus 23n plus 23 is 0. So you get 23 minus 23n is 0. So you get negative 23n is below than negative. So your negative is negative 23. So we will get 23 and is bigger than 2023. So and here you will get the value should be bigger than 87.95, or we can say n is equal to 28. This is the value of the first negative term. Okay, this is the arithmetic series. Okay, next we go for a geometrical series. What is geometrical series? A geometrical series is one in which the ratio, so the term key point is ratio of successive term, is a constant number. For example, you have 2, 4, 8, 16, 32. So it means it's a times. Then you have 2, negative 1, you have half, you have negative 1 over 4, you have 1 over 8, and the rest. So it defines the geometrical series, which is the general equation of Sn is A plus AR plus AR square plus AR cos cubic, okay, plus, and at the end is ARn minus 1. So in order to obtain the summation of Sn, so we have the first one is Rsn equal to AR square and ARn minus 1 plus ARn. So we subtract this for Sn minus Rsn, A minus ARn. So you will get your Sn value is A 1 over R power of n divided by 1 over R. So the sum of the first n term we can say is Sn is equal to summation from started from k equal to 0 to n minus 1. Your term is AR power of k, or A 1 minus R power of n divided by 1 minus R, which is if R is below than 1 and R is not equal to 1. If R is bigger than 1, the formula will be Sn equal to A R power of n minus 1 divided by R power of 1. So this R below of 1 is 1 minus R, R bigger than 1 is R n minus 1. Okay, for example, we have one geometrical series. The first term is 3 and the fourth term is 24. Determine the ratio to the A1. So we have a solution. So where is your A? The common ratio. So A is equal to 3. Then we know that the fourth term is equal to 24. So the question asks us to find the common ratio. So we know that formula A R power of n. So in this case, A R power of your n is n minus 1 will be 3. So equal to 24. What's your A? A is 3. What is your R? This is what we want to find. Okay. What is your R power of n minus 1? 4 minus 1. So you will get equal to 24. You will R power of 3 equal to 8. R equal to 2. So the B question asks us to find 7th term. So T7 is equal to R n minus 1. So what is your A? A is 3. What is your R? In this case, your R is 2. What is your n? 7 minus 1, which is 6. At the end of it, you will get 192. And the third one, the nth term. So it's Tn. So AR n minus 1. So here we get, what is your A is 3, what is your R is 2 n minus 1. So you will get about 3 over 2 power of n. Okay. Next example. We have determined the number of term in the following geometrical. So here solution is, you have your A is equal to 2, then you have your R is equal to T2 divided by T1, or 6 divided by 2 is equal to 3. So the question asks, what is the number of term? Tn. Tn is equal to the last one, 13122. So what is your Tn? The formula is Arn minus 1 is equal to 13122. Then you get your A is 2, your R is 3, and minus 1 is equal to 13122. Then you will get 2 over 3, 3 power of n is equal to 13122. So you will get 3n is equal to 16883 and is equal to log 16883 divided by log 3. Then your answer should be around 9. Okay. So we go for next example. Determine the number of term on the following geometric series which is beyond 6,000. So the solution is so you have A is equal to 3, you have R is equal to 6 divided by 3 equal to 2. Then the question is Tn beyond of 6,000. So you have A power of R minus 1 is beyond 6,000. So what is your A is 3. What is your R is 2 power of n minus 1 is beyond 6,000. Then you will get 2n equal to 4,000. And you get n is equal to should be bigger to log 4,000 divided by 2. So your answer is bigger than 11.96, or we can say n equal to 12. Okay. Another example we can see, determine the sum of the following geometrical series. Here the solution is, we know that your A is equal to 2, we know your R is equal to 2, then Tn is equal to 512. So Tn is Arn minus 1 is equal to 512. Then you have your A is 2, you have your R is 2, and minus 1 is equal to 512. So at the end you will get 2 power of n is equal to 512. Then your n value is equal to 9. Okay, so this is your n value. Now the question asks sum of the following. So the formula of sum is Sn is equal to A R n power of n minus 1 divided by R minus 1. R is bigger than 1, or R should not be 1. Then you have another formula which is A 1 minus R power of n divided by 1 minus R. Okay, if the R is 1 or R, in this case we know our R is 9, so means R is bigger than 1. So we use this formula. So your Sn is equal to, what is your A? A is 2. What is your R? R is 2 power of n. What is your n? N is 9. Minus 1 divided by 2 minus 1. So at the end you will get 1022. So this is the summation for T9. Okay. Okay, we go another example. Prove that this equation is equal to 5 over 88 10 to 21 over 90. So the solution is, so we have 5 plus 555 plus 555 plus 5555 20 terms. Okay, so we take out the 5s, we will get 5 equal to 1 plus 11 plus 111 1111. Okay, 20 terms. Okay, so here so we reverse it, we divide everything with 9, means here should be 9 plus 11, sorry, 5 plus 99 plus 999 plus 9999 in 20 terms. So means if 9, we can put the sequence to 5 over 9 divided by 10 to minus of 1, the first one, plus 100 minus 1 plus 1000 minus 1 and 10,000 minus 1. So in terms of 20 terms. So now you can take out the 5 over 9, you can take out the negative 1, so become negative 1, negative 1, negative 1, negative 1. Okay, dot dot dot, plus 10 plus 100 plus 1000 10,000 dot of 20 terms. So here we can simplify this one to become 5 over 9, okay, equal to negative 20 plus 10 power of 20 minus 1 divided by 10 power of negative 1. So you will get 5 over 9 negative 20 plus 10 power of 20 minus 1 divided by 9. Okay, then you will get 5 over 9 negative 180 plus 10 power of 21 minus 1 times 10 divided by 9. So here you can simplify, become 5 power of 81 times 10 power of 21 minus 180. So we have proof this.